Alright, so Assalamualaikum and good morning to all. So this is our class for EMJ37504, okay, for hours credit. Uh, so I would like to remind that today is the deadline for the Lab 1 report submission after 1 week and a few days. So you can submit your Lab 1 report at the Google Classroom. Okay, I already, uh, on the submission mode for the lab report 1. And also thanks for those who are coming for the lab session during last week. Hopefully who are attending the lab, you can benefit all the information that I gave through during the class. Okay. So for those who are not coming, I don't know, maybe you missed something that really important for the report. So I would like to advise, if you are here, and then when I do face-to-face meeting, hopefully you can join the meeting. All right. That's really important. Face-to-face and online, totally different. You can, hopefully, or maybe you can grab more knowledge during the face-to-face meeting. Okay, just spend a few hours in this semester for the face-to-face meeting. All right. So before I proceed, I would like to highlight again whatever we already covered during the previous class a couple of weeks ago. Where is it? Introduction, control system, state space to function. Yep, this one. Still loading. So I need to open again. This one. Okay, so during the previous weeks, the last topic covered is state space to transfer function. And then this is the second topic for this course. So in this topic, you already learned about the conversion between state space and transfer function and the analysis of the conversion system. Okay. So we are at this part. So the previous class, we just focused on how to convert the state space to transfer function only. Okay. And then after that, I do some comparisons between how to convert the state space between state space and transfer function, where the state space in time domain and the transfer function in frequency domain. Okay. And then we already used this formula to convert the state space to transfer function by using CSI minus A inverse B plus D formula. Okay. So after that, we are going through how to derive the formula from the state space. So we do some Laplace, and after that, we do some arrangement until we get the transfer function formula, output divided by input in frequency domain. And this is the formula that we obtain from the derivation. Next, I also explained to you how to do the inverse matrix for 2-dimensional matrix and 3-dimensional matrix. You can use this link to refer how to do it. I developed a technique called 3T transpose tutup tanda. Okay, hopefully you can develop by your own as long as you know how to do the inverse matrix. So after that, we do some examples how to convert the transfer function, state space to transfer function, okay, by using this formula. And then we go to the how to do it. And then after that, the second example. How many examples? And then after that, after we obtain the transfer function, we can know our characteristic equation, where the characteristic equation actually can be obtained from determinant Si minus A only. Okay, or you can see the denominator part of the transfer function. So at the denominator part of the transfer function actually denotes as the characteristic equation. And after that, based on the characteristic equation, we know that the system is unstable because we look at the post location. For this example lah. And after that, we go to the second example for the 3 by 3 matrix. Okay, by using the same formula, and then until we get the transfer function. This is the transfer function. Here, the final transfer function. And based on the transfer function, we can calculate the post location by looking at the characteristic equation, where the characteristic equation just denotes by determinant of Si minus A. Okay, so this is the characteristic equation. Yep, characteristic equation. This is can obtain from determinant Si minus A only. Okay, the characteristic equation generated by the determinant Si minus A here. Okay, and after that, we obtain the post location. And based on this, we can say that this state space actually is a stable system where the all posts are located at the left-hand side of the S plane. You will click at the post location here. Every post location is a negative, okay, or negative of the left side. And then after that, I give you two exercises to exercise. Hopefully, I've already done this exercise in order to determine, and then after that, you need to determine the stability of the system. Okay, so this is the answer. Hopefully, you do this exercise. All right, so done for what we have done on the previous class. So today, we will focus on the same topic. Okay, so now we want to convert from transfer function to state space. Okay, previously from state space to transfer function. Now we want to convert transfer function to state space. So this is number 2. So this is what we want to focus, the determination of eigenvalues and eigenvectors. Okay, and then I need to add some more. The conversion between transfer function to okay, so ni I change to 2 lah. Right. So done. Okay, so now we are focusing on this part. Pointer option, then we are focusing on this part. Transfer function to state space. Okay, according to transfer function to state space, at this part, so you can convert the transfer function to state space in 5 different forms. Firstly, phase variable form, and then after that, cascade or serial form, next parallel form, controller canonical form, so CCF, and finally observer canonical form or CF. All right. So today I will explain to you how to convert the state space to these 5 different forms. That's our target. And also our target today, also how to determine the eigenvalues and eigenvectors of the system. There are two. Firstly, how to convert state space to these 5 different forms. and also how to determine the eigenvalues and eigenvector of the system. Okay, so you can see that to convert the transfer function to state space, okay, actually you have this transfer function Cs over Rs, the same transfer function equal to S plus V3 divided by S square plus 10 S plus 24. Okay, you only have one transfer function. Okay, however, the transfer function you can convert to this form: phase variable. The same transfer function also you can convert to the parallel form, transfer function to the cascade. The same transfer function you can convert to the controller canonical form, and finally observer canonical form. So it means that although you have different of the state space, actually they are all are equivalent or similar. They are similar. However, only the form that is different. Actually, they are equivalent. Equivalent. So in the exam, maybe I can ask you, I give you a state space here, and I told you that I asked you to please uh, please convert this state space to cascade form. So you must refer to this form. Okay. So it depends because every form here have their useness. Okay, have their own useness. So that's why you need to know how to convert to phase variable, how to convert to parallel, cascade, control mechanical form, observer mechanical form. Every of these have its use. So for example, for the phase variable form, as I mentioned before, for the controller implementation here, you will learn two types of controllers only. First is pole placement and second is observable controller. Okay, so in order to design pole placement controller, you only must use in phase variable form only. So let's say if you want to design pole placement controller, but you use cascade form state space, you cannot design the controller. You are totally wrong. You cannot proceed everything. You only can design the pole placement controller if and only if you convert your state space in phase variable form only. Okay. So example, for the second controller that you will learn in this course is observable controller. You look at here, observable controller. You only can design the observable controller if your state space in which form. Anyone would like to guess? Ni ada angkat tangan Roslyn. Okay, anyone would like to guess? If you want to design observable controller, which state space that you must use? Afif, Aiman, nak test, nak try answer? Do you want to try? Try to read the form name, and I want to design observable controller. So which form that might be the one in order to design the observable controller?
We use observer canonical.
Yep, that's the answer. So if you want to design the observable controller, so you must use only observer canonical form only. Easy, yeah? Only so in this case, the two most form that you really must know or compulsory know to convert the transfer function to state space, there are two of them. They're really important. Phase variable form and also observer canonical form. The rest you must know lah. Just know a little bit pun okay. And but however, the most important is phase variable form and observer canonical form, because these two form you will use to design controller after we finish this topic. Okay, clear about this? Alright, so firstly, convert transfer function to phase variable form, PVF lah. Ada saya tak buat short form PVF to PVF. Actually, to convert from transfer function to phase variable form, you must follow this step. This is the question, transfer function. And then after that, you need to convert to this form. Okay, you can see that the numerator part you move aside. Okay, and then the rest you will be like this. Okay, and then after that, you need to convert to the signal flow graph. And after that, you can obtain the state space. This is the process actually. However, I will give you a very shortcut way in order to convert from transfer function to the state space. Okay. Firstly, what you need to know about the phase variable form, the basic structure. The basic structure for the phase variable form is x dot equal to x. I need to use this one lah, different lah. Yeah. Need to use my pad. Share screen. Start sharing. Start now. I need to rename. A minute Okay, I need to rename to state space. DF2 state space. Alright. The question is this one. Okay. The question is convert from CS over RS to S plus 3 S square plus 10S plus 34. So I will show you two ways, the long way and the shortcut way. Okay. Firstly, you need to separate the numerator and denominator part. Okay, and then you multiply with S plus 3. Okay, and then after that, you convert to this block diagram. 1 over S square plus 10S plus with 24. This is input. And then this is the numerator part. And this is the output. Okay. In this case, you just name the middle of parameter here is xs. Okay. So you can conclude that the CS over RS actually is coming from XS. This one is it. Multiply with the CS divided by XS. Same thing kan? So you can obtain lah the transfer function. So firstly, you know that for the first part here, the RS, sorry, the XS actually, the XS actually is 1 over S square plus 10 S plus 24, okay, multiplied with the RS, okay, and then you just multiply it there, so you can get S square XS, is it, plus 10 S XS plus with 24 XS equal to RS. And then by inverse Laplace them, you can get X double dot plus 10X dot plus 24X equal to R only, RT for input. Because this is already inverse Laplace. And then for sure you need to use this table. X, you can name X1. X dot equal to X1 dot equal to X2. And then after that, X double dot equal to X2 dot. Is it? And finally, you can get X2 dot equal to negative 10 X1, X dot actually equal to X2 plus with 20, sorry, negative minus, minus 24 X here actually equal to X1 plus with RT. So this is your X2 dot. Okay. And then after that, so you know that as a conclusion, you can say that X1 dot equal to X2 and X2 dot equal to this part. X2 dot equal to negative 24 X1 minus 10 X2 plus with the RT. Okay, done for the first part. Now we want to go to the second part. Here. For the second part, you know that we extract the graph there. S plus 3 and this is the CS. So it means that the CS actually equal to S plus 3 multiplied with the XS. We get SXS plus V3 XS the CS. So you inverse Laplace and finally you can get the this y actually equal to X dot plus 3X. Is it? The CT. And then after that, we just use the same thing, the table that we referred before. This is the table that we developed. Okay. So I write it again. X equal to X1. X dot equal to X1 dot or equal to X2. So in this case, we not use X dot equal to X1 dot because if you still remember, your state space equation Y equal to Cx plus du. So there is not no X dot in this. Okay, so that's why we use X2. So X2 plus 3X1, or you can see that the Ct actually equal to Y, T equal to Ct, 3X1 plus with X2. Okay, so finally, based all the information we have, we can say that X1 dot equal to X2 according to this thing that we conclude. X2 dot equal to negative 24X1 minus 10X2 plus with R and Y equal to 3X1 plus X2. So when we put it in the state space form, X1, X2, 3, 1, 0, 1, negative 34, negative 10, 0, 1. Oh, I need to sign off. This is X1, X2 plus with 0, 1, R. x1 dot x2 dot. So this is how you want to convert from the state space transfer function to state space in phase variable form. So the most crucial part that you must remember to this, just you must remember to this, you must to know the first step, the second step, and the third step. So this is the most important part lah. So you have the question here, and then after that you need to separate the transfer function into two parts, the numerator and denominator part. Okay, and then after that you need to name the xs here. Okay, the xs here, and then after that you need to convert to this part and you just solve it lah. Okay, this is the long way. However, I will show you how to do the shortcut to convert the state space to the transfer function. Based on this, the question is gs s plus 3 s square plus 10s plus 24. Okay, based on the longest way, the answer is x equal to 0 minus 24, 1 minus 10, x plus b 0, 1 r, y equal to 3, 1 x. Okay, so to do the shortcut way, you must know the basic form of the PPF. Firstly, you must know the basic form of the PPF. This is A, B, C, and D. The A must be in this form. 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, and this is negative A, negative B, negative C, negative D, and so on. So it means that if this is second order system, you must look at the second order. You just look first and second. Okay, so the A will be 0, 1, negative A, negative B. If second order system. Okay. So let's say if your transfer function is a third order system, you must look at this array. So it becomes 0, 1, 0, 0, 0, 1, negative A, negative B, negative C. If third order system. Okay. So let's say if your system or transfer function is fourth order system, so what do you think it will be? I would like to ask anyone would like to answer?
4 by 4.
If 4 by 4, it will be, at this part will be, so this is 2 by 2, 3 by 3. How about 4 by 4? So the basic form of the A matrix will be
0, 1, 0, 0.
0, 1, 0, 0.
0, 0, 1, 0.
And then
0, 0, 0, 0, 0, 1.
okay,
And then negative A, negative B, negative C, and negative D.
correct. That's correct. Okay, so this is for the A matrix. Okay, so now I want to teach you how to fill up this to get this value. This value, you need to look at the bottom part, the denominator part. and then you read from right to left. From right to left. Okay, so your right, the first right is 24, isn't it? Okay, 24. Since this is 2 by 2 matrix, so we just 0, 1. Okay, 0, 1. The A for this matrix. Since this is 2 by 2, we just refer to this one. Your first negative A here. We read from right to left. So we meet first is 24. So that we need to negative the numbers. So it will be negative 24. Okay. And then after we meet 24, we meet another 10 number. So this is positive value. So we need to negative the value become negative 10. So done for A matrix. So you compare, the answer is same. Okay. Done for the A matrix. So we go to the B matrix. B matrix. The metric form of the B always something like 0, 0, the last will be 1. So let's say if you have a 2 by 2 matrix, so it become 0, 1. Okay. So if your B matrix is third order system, your B will be 0, 0, 1. This is 3 by 3 by 1. Okay. And then let's say if your system is 4 by 4 matrix, your B will be 0, 0, 0, 1. 4 by 4 lah. 4 by 1 for order of the system. So you can check that your system is second order system. This one second order system. Automatically your B matrix will be 0, 1 only by default. Okay. And then for your C matrix, you just do the same, right at the numerator part from right to left. Right to left, right to left. So the first number on your right, when you move from right to left, the first number you see 3. So you just write 3. The second number is 1. So you just write 1. So you get the symmetric is 3, 1. So it's really simple. So in conclusion, we look at the question again. The ys over, sorry, the transfer function of the gs equal to s plus 3 divided by s squared plus 10s plus 24. If you want to convert to the phase variable form, firstly, you know that your A matrix will be need to read from here. Since this is 2 by 2 matrix, 0, 1 first. And after that, the first number you meet is 24. You need to negative the number. And after that, you meet 10. You need to negative the number. Then for the B matrix, this is for the C matrix. Okay. For the B matrix, by default lah, the last will be 1. The bottom line will be 1. The rest will be 0. Yeah. And then for the C matrix, you must write at the numerator part from right to left. However, you not need to negative the number. You just take the raw number. Okay, the first number you see is 3, and next is 1. So then finally, you can obtain the state space for this is 0, 1, negative 64, negative 10, x plus v 0, 1, u, y equal to 3, 1, x. Then, okay. So this is how we want to convert the transfer function to the phase variable form. Okay. So you can choose which method you want. You can choose either you want to use the derivation way, something like this, Okay, the method 1. You can choose method number 1, or you can choose the second method, method number 2. Method 2. Depends, okay? Depend on the question, and if did not mention, you can use method number 2 lah. If the question mentioned, then you use method number 1. Okay, for the exercise, can you help me to convert this thing back? Convert the transfer function to phase variable form. Let's say this one. The transfer function is ys over rs equal to s plus s square plus 3s plus 2 divided by s power 4 3s square plus with 4s plus with 5. Okay, can you please do this question? Convert the transfer function to the phase variable form. And then you can submit the answer in the WhatsApp group lah. So I will see your answer in the WhatsApp group. You can snap. Just use the simplest way only. So firstly, you need to obtain your A, your B, your C. Okay. Or we want to do it together. We do it together. All right. So firstly, what is the order of the system? Order. So it means that your matrix will be in what dimension? Your A matrix in what dimension?
4 times 4.
4 by 4. Okay. So can you please help me to fill up the first 3 row? Starting from here. So this one will be, at this point, what is the value?
0, 1, 0, 0.
0, 1, 0, 0. Next.
0, 0, 1, 0.
0, 0, 1, 0. Next.
0, 0, 0, 1.
0, 0, 1. And the last row will be what? By looking at the
-5, -4.
negative,
0, -3, -1.
-5, -4, 0, and -3. That's all. Sorry. I need to back here. Is it correct? -5. Okay. -4. And then -3. And will be what value here after that?
0.
0. Yep, that's correct. Okay. And then for the B, will be for the B matrix. So what is the B matrix will be?
0.
0. And after that,
0, 1.
0. How many 0? How many
3,
zeros?
0.
3 zeros and 1. Okay. How about the C matrix? Okay, so the C matrix will be panggil nama lah. Daniel Ashmawi. Okay, what is the C matrix, Daniel? Daniel ada tak? Daniel Ashmawi. Devendran. Why is the C matrix Devendran? Lagi cepat jawab, lagi cepat kita habis kelas. Devendran? Benar? Yes, what is the C matrix, Devendran? What is the C matrix? For this, look at the numerator part. Okay, hopefully during the class, you also need to bring your pen and paper. Okay, you pen and paper. While I am writing, okay, writing on the screen something else, or just project in the slide, you also need to write. Okay, although you are during online class, for this subject course, you cannot just listen. If you just listen, you can expect lower grade lah for this control 2. Okay, if you do it together with me, okay, from starting until the end, hopefully you will be okay lah for the control 2. Because this course, you cannot just listen during the class. You need to do together with me by using your own pen and paper. Okay, it's not only applicable to my course, it will be also applicable to all the courses that involve calculation. So it means that you cannot listen or you cannot learn this course when you are in the coffee shop, just or you just do something else. You must focus in order to help you to get a good grade for this course. Okay, and to understand everything. Okay, Devendran. So what's the answer, Devendran, for the C matrix? No, for the C matrix. So for the C matrix here. Okay, Devendran, for the C matrix, which part you need to refer? Numerator or denominator? Your friend already answered that the answer is correct. Nurul Fahana 2310. Okay, you must remember this is 4 by 4 matrix, so you must have the combination to match. Okay. So finally, to convert the transfer function to the PVF by using this fourth order of the system, the answer is 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, negative 4. X plus B 0, 0, 0, 1 U Y 2, 3, 1, 0 X. So that's why it's really important you pay attention or you do with me. So hopefully during the exam, not hopefully lah, I want during the final exam or BE or test, you did not cheating. Okay, so this is one of the way to avoid you from cheating by give 100% focus during the class. I know, I would like to remind you again, I know many of you cheating during the exam, so that's why in control 1, most of you cannot score in control 1. I think only 2 students got A for control 1, the rest got B, grade B plus, and so the rest lah. Although they are cheating, it's not only because they are cheating, because when they do cheating during the exam, the answer is wrong. Okay, because of this lah, focus during the class. Okay, hopefully what I talked today during this a few minutes you will take it seriously. Okay, and I would like to thank for those who give attention throughout the class. Okay, my duty is want you to know the knowledge before you are going to the real world of the after you are graduate. Okay, so done to convert from the state space to transfer function. Sorry, transfer function to state space phase variable form. All right. So we go to this one. Okay, done for the first part. Where is my Google Meet? Okay, all right. Okay, next. Transfer function to state space parallel form. Okay, this I will share to you lah how to do it. I will write here at this empty space, and you just need to refer to the slide later, because today I would like to explain to you the most important forms, phase variable form, and also the observer canonical form. Observer canonical form. Okay, the rest I will write down here, so you can refer after the class. But at least you must know how to do it. Okay. So the final form that I will also explain here is the observer canonical form. Okay, for the observer canonical form, actually it's same thing with the phase variable form. Okay, so the pattern same. Let's take for 10. Okay, so I will share here again. Share screen. We use the same. We use the same thing, same transfer function. So the GS equal to S plus 3 over S square plus 10S plus 24. So I will show you how to do the shortcut way. The shortcut way, you must know the basic form of the OCF, transfer function to OCF. Okay, the shortcut way you must know the basic function of this thing. A. So this is negative A, negative B, negative C, and so on. Okay, and then this will be negative A, negative B, negative C. I need to look at 0, 1, 0, 0, 0, 1, negative A, negative B, negative C. Okay, so it will be 0, 1, 0, 0, 0, 1. Let's say for the 3 by 3 lah. Okay, 3 by 3. The basic concept. And then the B here. And then the B here should be, for the A, you need to read from right to left again. Right to left again. However, for the A matrix, you need to fill up in this direction. Okay, so in this case, because this is 2 by 2 matrix, so your A matrix will be negative 24, negative 10. Okay, since this is 2 by 2 matrix, you will become 0, 1, 0, 1. Okay. Okay, for the B matrix, you need to read for the numerator part. Okay. So you need to fill up, you need to read from right to left again. So, but however, you need to fill up from bottom to top. So the first is 3, second is 1. Okay. And then for the C matrix, you need to start from 1, the rest will be 0. Okay, since this is 2 by 2 matrix, will be 1, 0 only. Okay. So I would like to make a conclusion. This is the easiest conclusion for you lah. Okay. So based on the same transfer function, if you convert to the phase variable form, you got this one. If you convert to the OCF, you got this one. Okay, so you can see that you also can refer to convert from LCF based on the PVF structure. So you can see that this is negative 24. This is negative 24. However, you just transpose. You just move negative 10 here, so it becomes negative 10. Okay. You just need to rotate lah. You just need to rotate. Okay. For this one, you just need to swap. Okay. And then firstly, you just write 3, 1. That's why 3, 1. This is 1, 0, 1, 0. So let's say if you have this kind of the transfer function, s square plus 3s plus 1, s cube plus v, then s plus 24s plus 3, example lah. So what you need to do, if you want to convert to the OCF, okay, you need to read from left to right. However, the direction you need to fill up from bottom to top. Negative 3, negative 24, negative 10, something like that. And then after that, if you still remember that for the top part here, you need to 0, 1, 0, 0, 0, 1. Okay, if 3 by 3. So in this case, you just need to write it again from bottom to top. This one you need to write from left to right, is it? 0, 1, 0, 0, 0, 1. So in this case, you need to write the same pattern, 0, 1, 0, 0, 0, 1. Something like that. Okay, so the same pattern, 0, 1, 0, 0, 0, 1. 0, 1, 0, 0, 0, 1. However, the direction for the OCF from bottom to top. For the PVF from left to right. Okay, so this is for the A matrix. Last bit, for the B, you need to refer to the numerator part. 1, 3, 1. Read again. So you need to write from bottom to top. 1, 3, 1. R. Okay, and then for the output, Y, you just write 1, 0, 0, X. So this is the answer lah. How to convert from the transfer function to OCF. Okay, so as conclusion, transfer function to PVF, transfer function to OCF, you need to write from bottom to top, PVF from left to right. Okay. However, from the transfer function here, let's say you have num and denominator, you need to read from left to right for both. Sorry, right to left for both. However, when you extract the information, you need to put in this direction, left to right, for the PVF, for the OCF, bottom to top for the OCF. So for the exercise, I want you to convert this transfer function to the OCF and PVF. Convert the transfer function to OCF and PVF. So the x dot equal to, not this one, gs equal to s plus 3 s cubed plus with 4s squared plus 5s plus with. Okay. Can you do it now and submit also in the WhatsApp group? Please do it now and submit your answer in the WhatsApp. Okay. So I need to stop the recording first for the first part, and after that the second part.